Dear students, this is the 13th lecture on interpolation. In this lecture, we will cover the topic interpolation for unequal intervals, in which today we will discuss about the method Newton's divided differences formula. Okay, students, as we are aware that interpolation is the technique of estimating or obtaining the value of the function for any intermediate value of the independent variable. Suppose we have to given the following set of values. Suppose we have to given the following set of values. X, x0, x1, x2, x3, xn, and corresponding values of y or functions are suppose y0, y1, y2, y3 and yn, and these set of values, this given set of values definitely may be connected by some function. Suppose this set of value is connected by the function y equal to fx. Okay, we have to given this kind of data, and we have to find out value of function or value of y for any intermediate value of the independent variable. Here the values of x are not in equal interval. These are not in equal interval. Okay, that's why here we can't apply here Newton's forward or Newton backward interpolation formula or Gauss forward interpolation formula, Gauss backward interpolation formula, or Stirling formula. Okay, here values of x are in unequal interval. That's why either we can apply here Lagrange's interpolation formula or Newton divided differences formula. This method is also capable for both unequal interval as well as for equal interval. Okay, when we can solve any problem for unequal intervals, definitely we can solve it for equal interval also. If the name of the method is not mentioned in your question paper, then you can solve by using any method. Either you can apply here interpolation, Newton Lagrange's interpolation formula or Newton divided differences formula. Okay, you can apply any method, and I will show, and in my earlier classes I have already shown it. For some set of values, I have solved that question by the both method, by the Newton forward interpolation formula and also by the Lagrange interpolation formula. We get the same answer. Okay, so I will also show it for the Newton divided differences formula also in my next classes. Okay, suppose this is the given set of value. Now first we should understand what is divided differences. Okay, what are divided differences? Suppose we have to given this kind of set of data. Now what are divided differences? Now by the definition of divided differences, we have, suppose we have to find out divided differences for x0. Okay, then what will be the formula? Suppose corresponding value of x0 or x0 x1, then what is the corresponding value of the function here? That is, definition of this is y minus y0 upon x minus x0. Okay, suppose we have to given this kind of set of data. Suppose we have to find out divided differences for x0 x1, and divided differences are denoted by, it's denoted by divided differences are denoted by the operator this del. Okay, these are the, it can be denoted by this del. Now what will be the value of x0 x1? X0 x1, that is y1 minus y0, y1 minus y0 upon x1 minus x0. Okay, now we can find out divided differences for x1. This is divided differences for x0 x1. Now x1 x2, that is y2 minus y1, y2 minus y1 upon x2 minus x1. We can find out divided differences for x2 x3, that is x2 x3 is y3 minus y2 upon x3 minus x2, and so on. Okay, these are called the divided differences of first order. These are the divided differences of first order, which are the divided differences of first order, which are the divided differences of first order. Okay, now we find out divided differences of second order. That is, these are the divided differences of first order. First order. Now we find out divided differences of second order. How we can find out divided differences of second order? Divided differences of second order for x0, x1, x2. When we have three terms simultaneously, then we can say these are the divided differences of second order, and this is equal to x1, x2 minus x0, x1 upon x2 minus x0. In simpler fashion, we can find out other second order divided differences, that is x1, x2, x3, means this is equal to x2, x3 minus x1, x2 upon x3 minus x1. These are the divided differences of second order, and so on. We can also find out divided differences of, we can also find out other divided differences of second order. Now we find out divided differences of third order. Third order means we have to take four terms simultaneously. That is, suppose it is x0, x1, x2, x3. We have to take these four terms together for third order divided differences. This is equal to x1, x2, x3 minus x0, x1, x2 upon x3 minus x0. Okay. Now we can find out other third order differences also. That is x1, x2, x3, x4. That is, this is equal to x2, x3, x4 minus x1, x2, x3 upon x4 minus x1. Okay. In similar fashion, we can also find out others third order differences too. Now we calculate divided differences of fourth order. How we can find out divided differences of fourth order? Fourth order means here we have to take four terms, means five terms simultaneously. That is, here first fourth order divided differences will be x0, x1, x2, x3 and x4. Here we have to take five terms. Okay, and this is equal to x1, x2, x3, x4 minus x0, x1, x2 and x3 upon x4 minus x0. Similar fashion, we can also find out other fourth order differences also. That is x1, x2, x3, x4, x5. That is x2, x3, x4, x5 minus x1, x2, x3, x4 upon x5 minus x1. In similar fashion, we can also find out other higher order forward differences also. Okay. Now we can see, we can find out, we can also write these differences in our difference table. We can also prepare a difference table also. Here we have x, y, first order differences. These are the second order divided differences, third order divided differences, and fourth order divided differences. Suppose here set of values are given x0, and here we have corresponding value of y0. Here we have x1 and corresponding value y1. Here we have x2 corresponding value y2, and here we have x3 and corresponding value y3. Okay, now we have to find out, this is called the Newton divided differences table. Newton's divided differences table. Okay, Newton's divided differences denoted by this del. Now we will calculate differences of first order. That is, what we calculate first? Differences of first order. That is x0, x1. That is x0, x1. What is this x0, x1? This is equal to y1 minus y0 upon x1 minus x0. Okay. Now next second order differences means here we find out x1, x2. This is equal to y2 minus y1 upon x2 minus x1. Next we calculate x2, x3. This is equal to y3 minus y2 upon x3 minus x2. These are the differences of first order. Okay, now we calculated differences of second order. We calculate differences for these two. That is for these two, that is, this is called x0, x1, x2. x0, x1, x2 is equal to, see here, this is equal to x1, x2, x1, x2 minus x0, x1 upon x2 minus x0 minus x0. Next we calculate differences for these two. That is, we have to find out x1, x2, x3. This is equal to this minus this, that is x2, x3 minus x1, x2 upon x3 minus x1, x3 minus x1. These are the differences of third order. Okay, here we have only 4 values. That's why we didn't get here differences of fourth order. Now we have to find out differences of third order. How we will get the differences of third order? That is, how we can find out x0, x1, x2, x3 is equal to this minus this, that is x1, x2, x3 minus x0, x1, x2 divided by x3 minus x0. Okay, this is called a Newton divided differences table. Now, what is the Newton divided differences formula? Let us discuss the divided differences formula. Now we will discuss Newton's divided differences formula. Newton's divided differences formula. Suppose the given set of values are x0, x1, x2, x3 up to xn, and corresponding values of y are y0, y1, y2, y3 up to yn, and which are connected by the function, suppose y equal to fx. Okay, the given set of values are connected by the function. Suppose it is connected by this function y equal to fx, definitely which is a function of x, and which may be a polynomial, okay, in x. Now let us assume this function be y equal to fx, and suppose this is in the form y0 plus x minus x0 what we have to what is the Newton divided differences formula? This is the formula: x minus x0, x0, x1 plus x minus x0, x0, x1, x minus x0, x minus x1, and here we have x0, x1, x2 in this way, plus x minus x0, x minus x1, x minus x2, and this is x0, x1, x2, x3 plus that is general term we have x minus x0, x minus x1 up to x minus xn, and here we have x0, x1, x2 up to xn. This is called Newton divided differences formula. It can be also written as, this can be also written as y equal to fx y0 plus x minus x0, and this is function of f x0 x1 plus x minus x0 x minus x1 function of x0 x1 x2 and we can get general term, that is x minus x0 x minus x1 up to x minus xn, and function of x0 x1 up to xn. This is called Newton divided differences formula. Okay, and here x0 x1 we can, here these three values we can obtain. Here this is x0 x1, this is x0 x1 x2, this is your x0 x1 x2 can be obtained from here, here and here. Okay, and it can be proved very easily, and we can also prove it. This is a very simple formula and it can be proved very easily. In many examination it is not very much important to prove the Newton divided differences formula, but it's very simple and easily it can be proved. But in many examination it is not required to prove, but if you want to see how it can be proved, then we can see here how it can be proved. Suppose these are the given set of values x, y, x0, x1, x2, x3, xn, and corresponding values of y are y0, y1, y2, y3, and yn. Now, by the definition of divided differences, we know that x minus, now by the definition divided differences we have x x0, this is equal to y minus y0 upon x minus x0. Okay, and what it can be written as, this can be written as y equal to y0 plus x minus x0 and x x0, And suppose this is the equation number 1. Okay. Again, we know that the Newton divided differences of second order, that is x, x0, x1, this is equal to x, x0 minus x0, x1 upon x minus x1. Okay, it can be also written as x0 x1 minus x x0 upon x1 minus x. Okay, and negative sign may be cancelled out. This can also be written as x0 minus x1 upon my x0 minus x1 minus x minus x0 upon x1 minus x, and when this will be cancelled out. Okay, that is x x0 is equal to x0 x1 plus x minus x1, and here we have x x0 x1. Okay, now substituting this value in equation 1. Now putting the value of x x0 in 1, then what we have when we put this value here, we from equation 1, y equal to y0 plus, when we put this value here, we get here x minus x0, and simplify it, we get this term, and x minus x0, x minus x1, and here we have x x0 and x1. And suppose this is the equation number 2. Also, by the third order differences, we know that x x0 x1 x2, this is equal to x x0 x1 minus x0 x1 x2 upon x minus x2. Okay, like this. Now simplifying it, that is, here we get x x0 x1 is equal to x x0 x1 x2 plus x minus x2, and this is x x0 x1 and x2. Okay, now putting this value in equation 2. Now substituting the value of x, x0, x1 in equation 2. What we have when put this value in equation 2? We get here, on solving this, what we get? We get here y equal to y0 after multiplying this term, and after simplify we can get here x minus x0, x0, x1 as it is, plus second term we have to multiply this term here. Okay, what we get here? X minus x0, x minus x1, and here we have x0, x1, x2 plus x minus x0, x minus x1, x minus x2, x, x0, x1, x2. Okay, now proceeding similarly. Now what we get? We get y equal to fx is equal to y0 plus x minus x0, x0, x1 plus x minus x0, x minus x1, x0, x1, x2 plus, what is the third term? X minus x0, x minus x1, x0, x1, x2 plus x minus x0, x minus x1, x minus x2, and here we have x0, x1, x2, and we have nth term, that is x minus x0, x minus x1 up to x minus xn minus 1, and here we have x0, x1, x2 up to xn, which is called Newton divided differences formula, and this is called Newton's divided differences formula, which is a Newton's divided differences formula. Now let us take an example. so that this method will be clear to all of you. Now we have an example which is based on Newton's divided differences method formula. Okay. This is the problem. Given the values x, y or fx, 5, 7, 11, 13 and 17, and corresponding values of function is 150, 392, 1452, 2366 and 5202. What we have to do? We have to evaluate F9 by Newton's divided differences formula. Okay, we have to find out here the given set of values x equal to 5, 7, 11, 13, 17 and the corresponding values of function or y equal to y or fx is 150, 392, 1452, 2366 and 5202. Okay, we have to solve this with the help of Newton divided differences formula. Okay, now we have to prepare divided difference table. First we find out divided differences. First we will prepare the divided difference table. Okay, here we have 5, that is 7, 11, 13 and 17. These are the given values of x. Now, what are the corresponding value of the function? Here values of y are Here we have 150, 392, 1452, 2366 and 5202. Now we have to prepare difference table. We have to calculate here forward differences, Newton's divided differences of first, second, third, fourth order, divided differences of first order, divided differences of second order, divided differences of third order, and divided differences of fourth order. Okay, here we are writing divided differences. Now first we find out divided differences of first order. First order means here this is x0, x1, x2, x. And what is the definition of, as I told you, what are the divided differences of first order? How we can find out divided differences of first order? How we can find out x0, x1, that is y1 minus y0 upon x1 minus x0, and then x1, x2, y2 minus y1 upon x2 minus x1, and x2, x3, y3 minus y2 upon x3 minus x2. Okay, that is how we can find out x0, x1. Definitely this will be the value of x0, x1, that is 392 minus 150 upon 7 minus 5. y1 minus y0 upon x1 minus x0. And on solving this, what we get here? It is, here we get 121. Okay. Now we find out other divided differences of first order, that is 1452 minus 392 upon 11 minus 7. 11 minus 7. What we did here? y2 minus y1. y2 minus y1 upon x2 minus x1. Okay. And this value is called x1, x2. This is x0, x1. This is called x1, x2. This is called x2, x3. And this, how we can find out y3 minus y2 upon x3 minus x2. That is, on solving this, we get here 265. Now we find out next divided differences, that is 2366 minus 1452 upon 13 minus 11. On solving this, we get here 457. Now we find out next divided differences, that is 5202 minus 2366 upon 17 minus 13. 17 minus 13. On solving this, we get here 709. These are the divided differences of first order. Now we find out divided differences of second order. How we can find out divided differences of second order? Divided differences of second order means between x0, x1, x2. That is x1, x2, x0, x1, x2 is called x1, x2 minus x0, x1 upon x2 minus x0. Similarly, for x1, x2, x3, x2, x3 minus x1, x2 upon x3 minus x1. In this way, we can find out these differences. That is this term minus this term upon that term minus that term. For this second order differences, for x1, x2, x3, this term minus this term upon this term minus this term. Okay. That is, now we find out differences for these two. That is 265, this term minus this term, that is 121 upon this term minus this term, 11 minus 5, and on solving this we get here 24. Now we find out divided differences for these three terms. That is 709 upon, now how we can find out? Here we have 24, that is 457 minus 265 upon 13 minus 7. 13 minus 7. On solving, what we get here? 32. Okay. Next we find out divided difference for these three terms. That is, next order will be 709 minus 457 upon 17 minus 11. On solving this is 42. Okay. How we can find out this term? This term minus this term upon this term minus this term. In this way we can find out other differences also. Now we find out third order differences. Third order differences means which involve, in first differences it involve up to 4 term. That is this term minus this term. How we can find out for these two? 32 minus 24 upon 32 minus 24 upon 13 minus 5. 13 minus 5, that is 1. And for next, that is 42 minus 32 upon 17 minus 7. And this is also equal to 1. And for next order, for these two, that is this minus this, that is 1 minus 1 upon 17 minus 5, that is 0. Okay. Here this is the value of x0. Here this value is called x0. This is called x0. This value is called y0. This value is called what is this called? This is x0, x1. This 121 is called x0, x1. This is called x0, x1, x2. Okay. This is called x0, x1. This is called x0, x1, x2. And this value is called x0, x1, x2, x3, and this value is called x0, x1, x2, x3 and x4. Okay, these are the Newton divided differences from top to bottom. These are the Newton divided differences for corresponding to x0. These are the Newton divided differences from top to bottom. Now by the Newton divided differences formula, we know that now what we have here, we have here x0 equal to 5, y0 equal to 150, then x0, x1 is equal to 121, x0, x1, x2 is equal to 24, x0, x1, x2, x3 is equal to 1 and x0, x1, x2, x3, x4 is equal to 0. Okay. Now by that Newton divided differences formula, we know that fx is equal to y0 plus x minus x0, x0, x1 plus x minus x0, x minus x1, x0, x1, x2 plus x minus x0, x minus x1, x minus x2, that is x0, x1, x2, x3 and so on. And so on. And next term will be 0. Now we put all these values. What we get? Fx equal to y0. What is y0? Y0 is 150 plus x minus x0, that is x minus 5 into x0, x1, that is 121 plus x minus 5 and x minus x1. This is x1, this is x0, this value is x1, this is x1, this value is x2, this value is x3, and this is x4. Okay, that is x minus 5, x minus 7 into 24 plus x minus 5, x minus 7, x minus x2, that is x minus 11 into 1, and next term will be 0 because x0, x1, x2, x3 is 0. That's why we have next term 0. Okay. Now on solving this, what we get? When we simplify this, what we get? Here we get fx is equal to x cube plus x square. And what we have to do? We have to find out f9. F9, that is 9 cube plus 9 square, that is 729 plus 81, that is F9 is equal to 810, which is the final answer. I think this method is clear to all of you. If you have any queries regarding this method, then you can comment on comment box. Definitely I will try to answer on your comments. And if you feel this video lecture is useful for you, you find out it is helpful for you, then it's my request, please like and subscribe this channel so that I can understand that you are watching my videos, and also press bell icons for getting notifications about my videos. Okay, thank you very much. Have a nice day and Bharat Mata ki Jai.